the element. You can assume it, you can put it 1. So usually in software what is done is if you don't give a thickness to the element, so nothing in this world is two-dimensional. Okay, so when you are making something from 3D to 2D, you are saying that whatever is happening in this 2D film is being extruded along the thickness direction. So you can give some value of the thickness, you may not give, and when you don't give to the software, it will assume a value of 1. Okay, and then you will have integration of B transpose D matrix, and you will have determinant of Jacobian, and you will have d epsilon d beta. Okay, so this is your stiffness matrix. Okay, so we have to get this thing today, and मेरे को पता नहीं मुर्गी पहले है कि अंडा पहले है, तो उसी तरह I do not know that this real coordinate to local coordinate system with a limit to -1 to +1 was done to have a better integration procedure, or was it vice versa that the integration procedure came later and for some other reason the local coordinates were designed for a limit of -1 to +1. That I'm not so sure of which one came first, but it happens to be so that because of such limits the integration becomes easier. Okay, and that we will see how. So forget about this because that's determinant, so that is going to give you a constant value. Just tell me the order of the matrix which you will have for a quadrilateral element. The number of rows and columns.
Like which matrix? B or like total?
B transpose DB. Okay. The whole thing. So, how many of you know what is D matrix? What is D? D for dog.
Stress matrix.
Huh?
Stress matrix. 1 nu 0 nu.
Yeah, that is not a stress matrix.
Is that D matrix? D matrix.
Yeah, what is D matrix? What you are saying, the values are correct. 1 mu 1 0 0 1 minus mu by 2. But what is it? ये क्या है, क्यों है? What is mu? Yes. Now you know it is Poisson's ratio. Now tell me what it is. Mighty, you have done some improvement. It appears that you have learned something. So you tell me what is D matrix. Don't go back to the same place. So D matrix we said is this, right? And this is strain. So it's just that. So what should be D? Stress is equal to D into epsilon. What is D?
What is
Elasticity. Right? So this D matrix for plane stress will be elastic modulus into 1 mu 1 1 minus mu by 2, and rest of the things are 0 0 and 0. Now you tell me the order of the matrix you will get. B transpose DB. ऐसे ऊपर देखने से नहीं मिलेगा, कुछ करना पड़ेगा कॉपी पेन से. 8 cross 8?
3 cross 8.
So you're getting 8 cross 8? And can you tell me why are you getting 8 cross 8? Well, of course, because they are multiplying rows and columns of matrix. But other than that, is there any other point of view? Yes. Yes. इसको मत करो, इसको you don't need to do this course. Yes, you are getting because there are 8 degrees of freedom. Right? So you have U1, V1, U2, V2, U3, V3. So now you should understand that as many number of this number of values in the column matrix of displacement, whatever number you have, that into that will be the order of the stiffness matrix. Okay. So imagine now we are not going to deal with one element, and for example, when we try to solve, which we will solve in the lab part, when we have, let us say, 10,000 elements, we rarely have 10,000 elements. We usually have 1 lakh element, 2 lakhs element, sometimes more than that. And that I'm talking when we do 2-dimensional analysis. When we have 3 dimension, we have more. Okay. One thing you also try to practice, anyways, we will do it in the class also. That, but there is nothing new there, except that you have to do more calculation. So what you should try to do is try to make this square a cube and add another dimension to it. Okay. So when it is a cube, then all the concepts which we have learned in 2 dimensions are valid in 3 dimensions. So you have to calculate. You know what will be the displacement matrix, what will be for this cube. तुम बताओ अभी कोर्स में पास हो जाओ, तुरंत हो जाओ, जल्दी बताओ. And they fall, these kind of elements, they fall in the rule of Lagrangian. So you can apply some elements, you cannot apply the rule of Lagrangian to find out the shape function. In some elements you can't do. For example, if you have a trigonal element, for this you cannot apply Lagrangian and you cannot find the shape functions using that formula. But for this one you can do.
Sir, in this, like, there are 8 vertices, so there will be 16 elements.
No. 8, yes. 16, no.
24.
Yes.
24.
Why 24?
3 coordinates.
Yes.
3 coordinates, sir. Yes.
X, Y,
No, sir,
Z.
X, Y.
X, Y, Z कहाँ आ रहा है displacement में?
3 freedoms. Degrees of freedom.
So tell me those 3 freedoms.
Like
U, V,
W.
yes.
Yes, sir.
Yes. So you have U1, V1, W1, U2, V2, W2. Okay, so displacement in X, Y and Z direction. So each node in 2 dimensions had 2 degrees, now you have 3 degrees, each of them. So it becomes 24. So for one element, the stiffness matrix will have an order of 24 cross 24. And now, so we can be in, so for this one, what you can do is, you will have epsilon eta and then you will have another one. Okay, so usko kya likhenge? Del
Omega.
omega likh do, z omega. Or omega, nahi, omega will, so you will have to make capital omega, otherwise omega will look like w. Okay, so you can try lambda or this, some notification you can, some notation you can use.
So why, like, in that triangle case, why you cannot find?
Because in this case, how will you assign the local coordinate? You cannot map it to -1 and +1, no? That you cannot do. Okay. Okay, so what you have to do is, what you have done in 2 dimensions, you have to extrapolate. So you have to make another one, and then you can imagine the shape functions will have epsilon, eta, and zeta. 3 things. Do you follow? So for 2 dimensions, you had shape functions like this, no? right? So for 3 dimension you will have another term, 1 plus or minus zeta, okay? And then same thing, you have to find Jacobian, and then you have to find the A matrix or whatever it was, then you have to find the B matrix, and once B matrix is there, you have this, so you can calculate stress and you can calculate this, and you are good to go. So you should try these things in tutorial, but first practice 2 dimension as much as possible, okay? Okay, so now you are saying that this will be of the order of 8 cross 8. So suppose I have now very simple case of 4 elements. So I have E1, E2, E3 and E4, and let us do the numbering also. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number of nodes. Okay, I have total 9 number of nodes. So what will be the size of the displacement matrix? 18. So stiffness matrix will be 18 cross 18. Okay, so this is happening for 4 elements. Duster कहाँ गया? Not that one. Somehow I keep it there. I don't know why and how. So now imagine that you have 1000 elements. Let us say 1000 is a very small number. So 1000 elements, how many values will be there in the displacement matrix?
2D.
2D, yes. 2000. Stiffness matrix का क्या order होगा? Now you imagine what will happen to RAM of your computer. Every time you are calculating this stiffness matrix, okay, and this stiffness matrix. So so for example, I apply a displacement of 2 millimeter on this side, and this side I keep it constrained. Okay, so this is like a horizontal tensile assessment. Well, I have 2 millimeters there also, there also. Okay, so and now I am solving it with 1000 elements in it. Okay, so this 2 millimeter can be applied in one step. It can be applied in 100 steps. Okay. So I can simply apply directly 2 millimeter and do the calculation. For elastic problems, it is good. It is okay. There is no issue. Because in elasticity, things are going to be linearly related. Okay? But if there is plasticity involved, then beyond, when the stress crosses the yield strength, then you have calculation at different values of strain, right? So in each element, when the strain progresses, you have some changes in stress, and that is being calculated. If suppose that the yield strength is crossed after a displacement of 1 millimeter, okay, and I am doing it in one step, so I have applied whole of 2 millimeter, okay, so that means it is in the plastic region now. So after plastic region, it has only one point for calculation because I am applying it in one step, so it is going to get one value of stress, okay. And now suppose I do it for 10 millimeter, but with a step of 2 millimeters. So for 10 millimeters, I'll get 5 points, right? So 1, 2, 3, right? So I don't have values here. It looks like it is linear. So in order to have more refined or accurate values, I need to decrease the number of steps, right? So as many number of steps I decrease, so now let us say I apply this 2 millimeter in 100 steps, okay? So in each step I apply 0.002 millimeter and do the calculation. So for these, every increment of displacement in every element, this stiffness matrix is being calculated. The global stiffness matrix for 1000 element is of the order of 2000 cross 2000. Okay, so how many values you have?
4 into 10 to the power 6.
4 into 10 to the power 6. 4 into 10 to the power 6 values must be calculated, and computer will allocate space for that. Right? 4 into 10 to the power 6 space has been now blocked to put the values there. And this is happening in each increment, and you need to know the value before. You can't lose it unless it is written. Even if it is written in the software in some output file, you need to access that. So again you will use it. So again you will block those spaces. So 100 into 4 into 10 to the power 6. 100 into 4 into 10. So 4 into 10 to the power 8 number of locations will be blocked. Right? So if you do it on your laptop, which you will be doing, it will melt probably. Or if you have less RAM, then your computer will get hanged. What can we do to avoid it? Good, very good. RAM बढ़ा सकते हैं. I wish we could do that. But that is not a solution. You have bought your laptop. Yeah? And if you have a lot of money and you can keep on buying laptops, then that's a different thing. So what else can you do about it?
Elements कम करने पड़ेंगे.
कैसे कम करेंगे एलिमेंट? तब तो you will lose on accuracy.
Some functional exponents.
What?
You have said to get accuracy, then we can do two things. Once we can add more numbers.
Yeah, H refinement, P refinement, that you can do. But in both cases, the stiffness matrix will have a more number of values. So if I take one element like this, okay, and if I refine it, if I do H refinement, that means out of this element I am creating 2 elements, 4 elements. I am making smaller elements now. That is H refinement. Okay. If I do that, so I made it 4. Then how many degrees of freedom I have now? 18. I'll have 18. The second option is to do P refinement. So I make it quadratic shape function, which will mean that there are mid nodes. So again you will have, well, less number of degrees of freedom. So a little bit less. That is correct. A little bit less in comparison to that one. So here you have 9, here you have 8. So 2 values you have decreased. Good. Apart from that, what else can you do? It has to come from your computer science knowledge, not from the theory which we are reading.
Dynamic programming.
Itna mere ko
Sir, like we can divide the element into smaller set depend on the basis of the symmetry, and then
say it again.
Like we can divide the elements into smaller symmetry, and then we can means
Smaller symmetry.
symmetry, and then we will reduce the size. Like we'll reduce the size and store the value of individual elements.
Yeah, that you
Individual
cannot do.
symmetry.
As much as I understand from what you are saying, any finite element model already reduces the problem based. Okay, fine. So think about it. What else can you do? And if you remember all those matrix So let me put it in the projector. Sufficient charge.
एलिमेंट्स को स्टोर करके बढ़ेंगे तो फिर ग्रेड भी आ जाएगी बार ट्रैवल्स करना पड़ेगा
So have I defined D in this? Yeah. So D is there. So let me define D matrix. So D will be some value which I am not writing for elastic modulus. So I will have 1 and K. दिखने के लिए क्यों? Where is K? Oh, इसमें value डालना पड़ेगा. So into D into 10. So now what is K? Well, it's not that good of a matrix. Yeah, it's not a good example. So, but what is temp is also not free, no? Or is it free? Try to find out strain. So we multiply with nodal displacement values. Well, derivative of that, and then we have 1 0 0 0 0 0 1 0 1 1 0. This kind of matrix, right? Yeah. So you look at this. You look at B matrix. And when you look at real examples of stiffness matrix, you will see something common. What is common? What is there? Which value is there in all these matrices? Which is a common value which is there in all these matrices? 0. You have a lot of zeros. You have a lot of zeros in most of the matrices. Okay, and this can be used to decrease the amount of RAM needed by using sparse matrices. Okay, so if you write a matrix and the values are 0, you are still using the locations. But if you, from the first hand, and that you can do in MATLAB, from the very beginning, if you make each matrix sparse matrix so that only those values are written where there are real values, then you can reduce, and this reduction in the capacity of computer is very high, and it increases exponentially as the level of problem increases, number of nodes increases. Okay, so now let us look at this thing, and we know that from one element of such type we are getting 8 cross 8 values in stiffness matrix, right? So K for one element is 8 cross 8. So I have 1, 2, 3, 4, 5, 6, 7, and 8, and then I will have here 1, 2, 3, 4, 5, 6, 7. And each value I can call as K11, K12, K13, and so on. Okay. So here I will have K11 and K12. Then I will have K21, K22 there, K31, K32 there, K41, K42 there. That is for this element, right? Similarly, I will have a stiffness matrix for this element. I will have a stiffness matrix for this one. I will have a stiffness matrix for this one. Now I have to make a global stiffness matrix. I have to make a matrix which assembles all these locals. Okay? And how many elements or how many number of nodes I have? 9. For 4 elements I have 9 number of nodes. So I will have 18 here, 1, 2, 3, 4 and so on, and also 18 there, right? So how will I place them? I will place them as per the node numbers, okay? So I will take this stiffness matrix, okay, and I'll put K11, I'll put K12, I'll put K31, K32, K41, K42, okay? In this one also I will get K21 and K22. Also coming from this element, it is also coming from this element, it is also coming from this element, it is also coming from that element. So what will be the real value of K21? Summation of all these. Okay? I will have summation of all the K21s which I am getting from the local, and I will add them. K11, so K41 for instance, and K42 will have no contribution from any other element. So they will be untouched. Okay? And by assembling these, I will make the global stiffness matrix. Similarly, I will make a global displacement matrix where I will have all the values of U1, U1, B1, U2, B2, U3, V3, and then so I will have U11 for each node, and then I will have for different nodes U11, U22. So for this one I will have U81 and U82, right? So I'll make the global displacement values also. Okay. Now I have made the global stiffness matrix, and now let us look at the integration. How we will do the integration? So this discussion was to assemble the stiffness matrix, but whatever order you get, you are getting the order of the matrix, but how do you get the value? You will get the same order, 8 cross 8 you will get, okay? But what will be those values? In order to find those values, you need to do the integration. It's not the multiplication of these matrices. It's not just that, right? They are functions of epsilon and eta. B is a function of epsilon and eta. D is not, right? But the total multiplication is a function of epsilon and eta, and you have to integrate them from -1 to +1. So how will you integrate it? Hello? Karo, integration karo. You are so good in maths. No? Me. Now. Okay? Have you heard of this? Gauss तो सुना ही होगा. Quadrature is not a name of any scientist. Okay, good. So if you have an integration of -1 to +1 f of x dx, then this can be written as summation of some weight function and the values of the function at different places. Okay, so wi fi, summation of that, y5. Yeah, so it can be w1 and f of something, or it can be w1 f at x1 plus w2 f at x2 and so on. Okay, so this is Gauss quadrature. It's done. This is how you do the numerical integration. But the point is, how do you get the values of weight functions and how do you get the values of the function at particular points. So these points, which are some location from the function, are called Gauss points. Right? You know why they are called Gauss points. Okay. So the property of Gauss quadrature is that if you have n number of unknown parameters, then you can handle a polynomial of the order of 2n minus 1 accurately. If the polynomial goes to a higher order, then the results are not accurate. Okay. So suppose I take 1 point Gauss quadrature. So I have two unknowns, w1 and x1. So in this case, well, I have written x. You can also write epsilon because the functions are in epsilon and eta. Okay. So if it is a one-dimensional element, you only have epsilon. So there are two unknowns, w1 and epsilon 1. Okay. Epsilon 1 is really not an unknown. Epsilon 1 is the coordinate of any point where you want to calculate this. So the real unknown is f of epsilon 1. Okay. So if you have now two unknowns, so 2 into 2 minus 1. Okay. No, this is wrong. So this should be the sampling points. If you have one sampling point, and in this case you have one sampling point, in this case you have two sampling points. Okay. So then it will go to the order of how much? 1. Right? So 2n minus 1 will be 1, right? So you can take a polynomial of the order 1 which can be solved using one sample point. Is it okay? So let us say that our function, okay, and we are saying that it will be accurate, so there will be no error, right? So if there is no error, then integration of this function, which is this, so a0 plus a1 epsilon d epsilon minus, so it should be equal to whatever we get from Gauss quadrature, right? So minus w1 into f of that, so a0 plus a1 epsilon. This should be 0 because that will be the error, right? So now if you try to solve it, what do you get? So integration of this will be a0 epsilon. Where is Vipin? Hi. So and then you have a1 epsilon square by 2, and this goes from minus 1 to plus 1, and here you have w1 into a0 plus a1 epsilon. So what do you get from here? f1, f of epsilon 1 or x1. Okay. So now if you take a0 common, what do you get? 2 minus w minus that. So w1 a1 epsilon 1 is equal to 0. So in order to have this thing equal to 0, can we get the values? Can we guess something? So if I put w is equal to 2, then this will be 0, right? Why I have written w? It is w1, no? But ये कैसे common हुआ? इधर तो w नहीं है, right? And if w1 is 2, what will be the value of epsilon 1?
0.
नहीं, epsilon 1 की value तो find ही नहीं कर सकते. कर सकते हैं. Epsilon 1 should also be 0.
If a1 is not 0.
If a and a, of course they are not 0.
Then epsilon.
Then epsilon.
They cannot be 0. So epsilon 1 will be 0. So then our sampling point becomes this and weight factor becomes that for a linear function. So we can try this. We can try this for f of x is equal to 1 plus x, and we need to do this integration karo. Minus 1 to plus 1, 1 plus x is equal to x plus x squared by 2. So this becomes what? 1 plus half, 3 by 2 minus. So this will be minus 1. So this becomes minus half, right? Is it correct? Just check.
Yes.
Yes, sir.
Yes.
See the 1 हो गया.
नहीं सर 2
माइनस प्लस हो जाएगा सर, माइनस माइनस प्लस
माइनस 2 बार आएगा सर.
W1 into f at 0 value, right? So W1 is 2 and when you put x is equal to 0 it is 1. Oh, ये तो बहुत simple था. You are getting the exact result. So in that case what will happen? X plus x cube by 3, right? So then we will have 1 plus 1 by 3, right?
8
So we
by
have
3
1 plus 1 by 3. It becomes 2 into 1. So you are not getting it. So 2n minus 1 in this case is, in this case 2n minus 1 is, so this is second degree polynomial, no? So n should be 2 plus 1, 3 by 2, which is 1.5. So at least you should have 2 sampling points. 1.5 sampling point नहीं हो सकता है. Okay? So then you will have to use this. And for this case, where is Chandru Patla? Here. So for 2 points Gauss quadrature, we have W1 is equal to W2 is equal to 1, and epsilon minus epsilon 1 is equal to epsilon 2 is equal to 1 by root 3. Okay, so these are the 2 sampling points and the 2 weight functions. I is equal to W1 f of 1 by minus 1 by root 3, no? Plus W2 is 1, so I don't need to write it. So f of 1 by root 3. So f of minus 1 by root 3 will be how much?
1 by 3.
1. Right? So you will have functions of epsilon as well as eta. So one time you will integrate with respect to epsilon and the next will be with respect to eta, and that's how you will calculate the value of the integration. Okay? So you should try some examples for calculating Gauss quadrature. Don't worry about the weight values and sampling points. That will be given if they are asked in exam, unless I ask you to derive it. If there is a numerical problem where you need to find the value of the integration, weight functions will be given, unless I am also